In this video, Justice and Mercy Energy Services is going to define electric current.
Okay, if we're going to be analyzing electric circuits, we need to ask ourselves, what are electric circuits and what's the fundamental stuff of an electric circuit? And the answer is charge. Charge is the fundamental stuff. Charge on electrons, which is negative, and protons, which is positive. And of course, these are together in one atom. And these are electrically neutral. Atoms are electrically neutral normally. And they have the equal numbers of protons in the nucleus and electrons in the orbitals. Now, one of those electrons out in the valence band is easily removed by some other phenomena, external phenomena. Then if it's removed, it's going to leave behind a positively charged atom, because now the number of protons exceeds the number of electrons by 1, and so there's a net positive charge on that atom. So here I've drawn 3 little atoms with their nuclei, and we're assuming they're all neutral, okay? Now if I take one of those electrons away, then I've left behind a net positive ion. But a neighboring valence electron from a neighboring atom might fill that hole with its electron. And if it does so, then that the first atom is neutral again, and now the hole has moved to the left. So the idea is if I move electron flow in one direction, say to the right, then hole flow moves in the opposite direction to the left. And we're going to analyze hole flow in this class. This is going to be about traditional positive current, the flow of positive charge, and when we define current in this class. Now, if I look at a piece of wire here, and I've drawn my little eyeball here looking at a certain cross section of this wire, and I've got some positive hole flows moving down this wire, I can define current as the change in charge that passes through that little shaded area in the middle in a given amount of time. Okay, that little shaded area, then I can sit there and watch it like with a stopwatch or something. Now, so if we use I as current and delta Q is for change in charge in coulombs, delta T is change in time in seconds. Now, by the way, a coulomb, as you may recall, or may not, is approximately a billion electrons. So the unit of the charge on an electron or a proton is so small that we can't really use it. It's like a penny. Nobody prices things in pennies. They price things in dollars, which is 100. Now, and the difference here is a billion is a little bit more than 100. Anyway, the unit of amp is what we use for current, and we say that's 1 coulomb per 1 second. Now, another thing to note is that current has it can be thought of kind of like a vector. It has to, when you're specifying it, at least for the purposes of electric circuit analysis, you need to specify both its magnitude and its direction. Now, its magnitude could be unknown. It could be something like IA here, or it could be IB. But notice I've drawn an arrow to indicate the direction, and I've also given it a name. If I draw an arrow without the name, it's incomplete. If I give a name without an arrow, it's incomplete. That doesn't tell me enough. If I ask you that on an exam, what that current is, you say I don't know because you didn't draw the arrow, man. So I could also have numbers. I could have, instead of IA or IB or IC, I could have 5 amps, or I could have a negative number like negative 2 amps, or I could have just unknown current I that I would need to solve for as part of the problem. That's current.
Justice and Mercy Energy Services installs, designs, and maintains solar energy systems in Haiti to combat energy poverty and create jobs. If this video was helpful to you, please consider making a donation. Thank you.